So number 5 on page 38, we have another compound inequality. This compound inequality is an OR situation, so I kind of anticipate that it means when I make my graph, they're going to go in opposite directions. But I just solve each part of the inequality separately, and then after I've solved, I can put them on the graph. They're going to share the same number line. So in this case, we are going to distribute I don't have any like terms, so I'm ready to add. So I'm going to add 3. Then we're going to divide by -6. And since we divide it by a negative, you know it, we got to flip the sign. So the sign is going to change direction. 2 negatives make that a +2. So for our inequality on the left, that portion of the compound inequality, we get x is greater than 2. So open circle at 2, and our shading is going off to the right. Or we have the one on the left, the other one on the right. So I'm going to take away 1. Now don't forget that there's a negative sign attached to that x, and we cannot leave things like that. So basically we need to divide by -1, or you need to change the signs, but it's going to change all of the signs, including the symbol, because it is the same thing as dividing by -1. 4 divided by -1, -4. So close circle at -4. And this shading is going to the left. So it's like the inequalities that we've done previously. With an OR situation, there are just 2 of them that share the same number line. So there is a second kind of compound inequality, and that is the AND situation. Occasionally you will actually see the word AND, but usually they are just kind of squished together. So AND inequalities we graph between. And the reason it says a tendency to graph between is because there are always those special cases, right? There's always that situation that it doesn't work for. But the tendency is that they're going to graph between. So we're going to be between the endpoints. So if I say x is greater than or equal to -6, and it's less than or equal to 1. So that's from -6 to 1. It's the things between there. Both things have to be true. So really, the negatives greater than -6, greater than -6 really goes all the way out here. Less than -1 goes or less than 1 goes this way. But this stuff in the middle is the only part that makes both of them true. And when it's AND, they have to both be true. So don't bother with going all the way both directions. We just want to shade the part that's between the 2 numbers, because that part satisfies both. And so typically this is going to be written in a more condensed form. So for example, if I have x is greater than or equal to -6, and, so I'm just rewriting what there at the top, x is less than or equal to 1, then I could just write smallest, largest at the end. X is between. Now, notice what had to happen when I squished that together. What had to happen when I squished it together is the x for that first part, The x is on the other side. So the symbol followed the x. It's still open to the x. So when you see the x in the middle, it means x is between those two numbers. So x is between -6 and 1. That's the same thing as if I wrote x is greater than or equal to the -6, and it's less than or equal to the 1. So when we see a problem that is an and inequality, so even though we don't see the word and here, since the x is in the middle, this is the same thing as if I wrote just this part on the left, that's like that problem, and this problem. But we're not going to write them twice. We're just going to leave it all pressed together. And some of you like to draw a line when you solve an equation. You're going to put, if you'd like to do that, you're going to put 2 lines here. You are not trying to get the 2 and the 9 together. Remember your focus when you solve an equation or inequality, get the variable by itself. So we're going to subtract 4, but instead of just doing it here and here, we have to also do it over here. So this is like a short way we can solve both parts of this inequality at the same time. This is by itself now. So 2 take away 4 is -4. Keep my symbol, x, and keep my symbol, and 5. So I made my lines way too long. So this looks like this. So whatever I need to do to get x by itself, I'm doing it not just to the middle with the x, but to the number on the left and the number on the right. So then I have a closed circle at -2, an open circle at 5, and my shading is in between. Just like the x is in between. So that one was just one step, but I had to do things in 3 different places instead of just, quote, both sides, because the x is being compared to 2 different numbers, not just one. So just always focus on the middle and trying to do what you have to do to get the x to be by itself. Give you guys a minute, make sure everyone has that before we look on at number 7 where we have 2 steps. Everyone good? Okay. So on number 7, if I look at the middle, I see that x is being multiplied by 7 and we're subtracting 13. So we're going to get rid of that subtraction first. We're going to get rid of that -13 by adding 13. And we're going to add it to the 8. And we're going to add it to the -27. So this is gone. Each step we should be getting closer to the x being alone. So -27 and +13 have -14. Keep my less than sign. 7x now. And then 8 plus 13, 21. And then now everything is going to get divided by 7 because that's what's necessary to get x by itself. So each number gets divided by the 7. So -2 is less than x, which is less than 3. So this time x is between -2 and 3. Does not include either of those numbers. They both get open circles, shading in between. So if you see the x in between, your shading is going to be between instead. So for number 8, what's our step 1? I want to subtract 4 or add 4, yeah. Yeah, get rid of that subtract 4, right? So we're going to do that by adding 4. We'll add it to the 2 and to the negative 16. So negative 16 and positive 4, negative 12. 2 and 4 make 6. And the x is closer to being by itself. Now we'll divide by 3. So negative 4. 6 divided by 3 is 2. So at negative 4, do I have an open or closed circle? Closed, indeed. And at 2, also closed. And then, by the way, if interval notation for this would be from negative 4 to 2. And hard parenthesis, because the 2, negative 4 and the 2 are included. So it's saying from this number to this number. And there's not 2 sets because it's just the stuff between those 2 numbers, and that's all. So the interval notation is easier to write for these just because they only have that one little section of the graph instead of 2 sections of the graph. Ooh, we get a nice fraction on the next one. So the fraction is only with the x, so we can still subtract first. So negative 2, 2/3 x, that's gone, and then 4. And then remember, we can get rid of a fraction by multiplying by its reciprocal. So everything is going to, which means like it's flip-flop, everything is going to get multiplied by 3 over 2. Which means we're multiplying by 3 and we're dividing by 2. 3 over 2, 3 over 2. So that gets x completely alone. 3 times negative 2 is negative 6. Divide it by 2 gives me negative 3. X is now alone. 4 times 3 is 12. Divided by 2 is 6. Or I could do the division first and then do 2 times 3. Still 6. Once x is alone, I know, that's how I know I'm done, right? We're not trying, it starts out with 2 symbols. It still needs to have 2 symbols at the end. So don't try to get rid of like one of those numbers. If it starts out as a compound inequality, it's still going to need those numbers. Let's see, 1, 2, 3. So you can't see my numbers here, but I believe 1, 2, 3, I believe this is where it is. 6, that one is closed. And then all the way back to wherever negative 3 is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Open. Wherever that's, I want to say that's negative 3, even if I count it wrong. And then our shading is, of course, still in between. If you had to multiply or divide by a negative, which none of those, nor number 10, then both symbols would change direction. The symbols should never be going opposite directions in a problem like this. That would not make sense. So you'll see they go the same direction. All right, you have an abundance of problems. So on homework 14, just do the odds. that will be 9 problems. So remember, or your shading is going to go away from each other and it's going to be between. And you do not need to answer the part about the interval notation, but please do make your number line graphs and do give your answers, like your inequality answers. Don't just give me the graph and not give me the final solution set.